Let us consider a car moving along a straight line. At time t1, the velocity of car is v1. At time t2, velocity is v2. Similarly, at time t3, velocity is v3. Now, see the motion of car along straight line M, where O is the reference point. Take 2 points O and A of the moving car, where change in velocity equals to final velocity minus initial velocity. Change in velocity equals to v2 minus v1. And time interval between O and A equals to final time minus initial time. Time interval equals to t2 minus t1. Now, average acceleration, that is A average, equals to change in velocity upon time interval, that is A average equals to v2 minus v1 upon t2 minus t1 equals to delta v upon delta t. The SI unit of acceleration is meter per second square. Cut. The average acceleration explains the change in velocity in the given interval of time, but it does not explain how fast the velocity changes at any instant of time during that interval. To explain the instantaneous acceleration or change in velocity at an instant for a moving body, let us consider a velocity time graph. From the graph, change in velocity equals to final velocity minus initial velocity, that is v plus delta v minus v. That is change in velocity equals to delta v. Time interval equals to final time minus initial time equals to t plus delta t minus t. That is time interval equals to delta t. This implies average acceleration equals to change in velocity upon time interval, that is delta v upon delta t.